Hi everyone, let's take a look at number 11 on page 444. The angle between any pair of lines in Cartesian form is also the angle between the normal vectors. For the lines x minus 3y plus 6 equal to 0 and x plus 2y minus 7 equal to 0, do the following. A. Sketch the lines. B. Determine the acute and obtuse angles between these lines. So part A, draw a diagram, and as you're thinking about these two lines, there's a couple ways of doing this. One method is to start with the y-intercept and looking at the slope. A second method is to look at the xy intercepts. So by inspection, in the first case, the line is going to be x minus 3y plus 6 equal to 0. And what that means is if you want to find the intercepts, and I can write this on the side, the x-intercept is going to be set y to be 0, solve for x. So x equals to negative 6. So you can go to the graph, left by 6, make sure you label this point, negative 6, 0. Likewise, you can find the y-intercept. And to find the y-intercept, you have to set x to be 0, solve for y. So in this case, y equals to positive 2. So again, you go back to the graph. On the y-axis, go up by 2. Make sure you label this point 0, 2. Draw a straight line. Make sure you connect them with an arrow at the end, just like that. So likewise, if you look at the second case, the line is going to be x plus 2y minus 7 equal to 0. And again, you can find the intercepts. To find the x-intercept, you set y to be 0, you solve for x. X minus 7 equals to 0, x equals to 7. So you go right by 7. Make sure you label this. Likewise, you can find the y-intercept by setting x to be 0, solving for y. So 2y minus 7 equals to 0, y equals to 3.5. So back to the graph, you go up by 3.5. Again, make sure you label this. You can connect the points with a straight line and draw some arrows just like that. Now, in part B, they're asking you to find the acute angle and the obtuse angle respectively. So by inspection, you can tell this angle is going to be acute. Let's call this theta 1. And this is going to be the obtuse angle, theta 2. So from chapter 6, if you think about the basic concepts, chapter 7 as well, the basic concepts of dot products, you can write down the fact that cosine theta 1 equals to. Now again, when you think about the dot product, you can look at the normal vectors, which means in this case, the normal vectors are, let's go back and add this. So in the first case, the normal vector, let's call this n1, that's going to be 1, negative 3. Likewise, if you look at the second case, the normal vector, n2, this is going to be 1, 2. So when you're trying to find the angle between them, you can take the dot product of the normal vectors, 1, negative 3, dot it into 1, 2, divided by the magnitude of the corresponding normal vectors. So the square root of 1 square plus negative 3 square times the square root of 1 square plus 2 square. When you work this out on the right-hand side, this equals to 1 times 1, that's going to be 1. Negative 3 times 2, that's going to be negative 6. If you look at the denominator, that's going to give you 1 plus 9, that's going to be root 10. And 1 plus 4, that's going to be the square root of 5. This implies that cosine theta 1 equals to negative 5 divided by the square root of 50. Now, if you look at this carefully, this turns out to be a special angle. because root 50 is the same as 25 times 2, which is really 5 root 2. So if you divide the top and bottom by 5, that becomes negative 1 over root 2. Now again, you can take the calculator, you can work this out in degree mode, but if you recognize the special angle, this implies that angle theta 1 equals to 135 degrees. Now, if you go back to the diagram, we wrote theta 1 to be the acute angle. So what happened is they gave you the obtuse angle. So this is actually theta 2, whereas theta 1 will be 180 minus that, which is 45 degrees. So you can go back, label this. Theta 1 is going to be 45 degrees. Theta 2 is going to be 135 degrees. And that's how you can find the acute and obtuse angles between these lines. I hope this makes sense.